video is a how-to on writing formulas that contain a polyatomic ion. Before we start talking about polyatomic ions, I just want to do a brief review of the periodic table and how to identify the charge for monatomic ions. Here are the charges for elements that are located in the main groups. This includes group 1, 2, 13, 14, 15, 16, and 17. It's important that you take special note of the charges on the right side of the periodic table because often I have students label the charges backwards, -3, -2, -1, so make sure you have them correct. It's also important to note that there are certain elements that require a Roman numeral when writing their charges. For example, the ones labeled in pink are the ones that need Roman numerals. These include most of the transition metals and what I call the pass elements. The pass elements include lead, arsenic, tin, and antimony, and we call them the pass elements because they spell pass, P-A-S-S. It kind of looks like a Tetris piece too. There are also 3 other transition metals that are a special case. We call these the Zac elements because they spell Zac, Z-A-C. This includes zinc, silver, and cadmium. What's special about these Zac elements is that you must remember the charges for them. Zinc always has a 2+ charge, silver always has a 1+ charge, and cadmium always has a 2+ charge. A great thing about these Texas star periodic tables is that these little numbers here next to the B can serve as great reminders of that. These little numbers next to the B's can serve as great reminders that silver's charge is +1 and that both zinc and cadmium have a +2 charge. Now that's not the reason why those numbers are there. We just thought it'd be a great way for you to reference when trying to figure out the charge of our Zac elements. Now, a polyatomic ion is a group of elements that share a charge. Here is a list of polyatomic ions that the Texas Star reference card has provided. You're going to notice that there are a group of elements that share a charge. Now, this is the way that the state of Texas has decided to represent it. I think it's actually a better practice if we take the superscripts, which represent the charge, pull them over to the right, and then put the polyatomic ions inside of parentheses. This is a great practice because it will remind you to not touch the polyatomic ion that's inside of the parentheses, and that's very important when writing formulas. So our first example is calcium nitrate. The first thing you want to do is write out calcium and its charge, which is Ca with a 2+ charge, and then write out nitrate that you find on the back of the periodic table. Nitrate is different from nitride. Nitride is just nitrogen. Nitrate is actually on the back of the periodic table. So here we have calcium with its 2+ charge and nitrate with its -1, and the goal of an ionic compound is always to make the compound neutral. But with 2 positive charges and 1 negative charge, this is not a neutral compound. To fix this, we must add another nitrate, and now we have 2 positive charges and 2 negative charges. The charges must be equal and opposite and add up to 0 to form that neutral compound. Now we can write the formula. The formula should contain 1 calcium ion and 2 nitrate ions, so here is our final formula. We can also apply the Crisscross Method to these ionic compounds that contain polyatomic ions. And the Crisscross Method says that we can take just the numbers and crisscross their positions. The 2 will cross over, make a complete like an X shape, will cross over to go under the negative symbol, and the understood 1 would cross over to be a subscript for under the positive charge. So here is an animated version of the crisscross. Now in this case, the understood 1 is actually just going to stay an understood 1, and we always drop the charges once we apply the crisscross method because now we have a neutral compound. There's no reason to show the charges, and you shouldn't show the charges. That would be improper. And again, we get the same exact formula we just saw.